Hi, Year 12. Welcome to our first lesson screencast. Now, this is for exercise 5B, Earth Geometry, and this exercise is all about using longitudes and latitudes to find the distance between two places or 2 points on the surface of the Earth. For the purpose of this exercise, we make an assumption about the Earth. We assume that it is a perfect sphere and that it can be modelled with a radius of 6,371 kilometres. So that's the number that we assume that the Earth's radius is for all of this chapter, all of the work in it. The reason we have to make that assumption is because the Earth isn't actually a perfect sphere, and the radius varies all the way along the surface because of things like valleys, mountains, oceans, hills, all of those kinds of things. And it is actually way, way, way too complicated for us to take those things into account for now. So we assume the average radius of 6,371 kilometres all the way along the surface of the Earth. The first thing we need to talk about is great circles. Now, a great circle is a 2D circle that circumnavigates the Earth. So what I mean by that is it goes all the way around the Earth like this. So the red one that I'm drawing right now is a great circle because it goes around the Earth and it is a circle. But for it to be a great circle, it actually has to, the center of the circle has to be in the center of the Earth as well. So in this one I've just drawn, the center that I've drawn in, it's the center of the circle, but it's the center of the sphere that the Earth is as well. Now, what that means is because they have the same center like that, it means that the great circle I've drawn is one of the largest possible circles which can be drawn on the Earth's surface. And when I say one of, I mean it has the largest possible circumference of any circle that can be drawn on the Earth's surface, but it's one of them because this one here is also a great circle, drawn in a completely different location, but it also has that same circumference. So great circles are just the biggest possible circles you can draw on the Earth's surface. The reason we care about them, though, is because longitudes are great circles. So meridians of longitude are great circles. And what I mean by that is, for example, this red line here is the longitude meridian, 0 degrees. Okay. Now, it is it's half the length of a great circle along that meridian. So if I wanted to find the distance between the North Pole and the South Pole, I would use the length of the great circle and I would divide it by 2. And that's actually how we find the distance between things that are on the same meridian of longitude, is we find out whatever fraction of the total arc length they are, the total great circle length, and we multiply by that fraction. So just like arc length that we did in 5A. Now, what the longitude of a point actually refers to, though, is it refers to how east or west, how many degrees east or west it is from that red line that I've drawn over, from the prime meridian there. So, for example, this line here is 30 degrees away from it if I drew out from a point in the center of the Earth. So there's a 30, if the center of the Earth is in here, and I can draw a line to that point and draw a line to that point, that'd be 30-degree angle in here. So that's what the longitude is actually referring to. Now, just a few facts about these lines of longitude. We call them meridians. They run in a north-south direction as they go from the top of the Earth to the bottom. We measure the distance of them as east or west in degrees from that prime meridian. They're farthest apart at the equator and they meet at the poles. So that we're referring to like the distance in between them here. It's the farthest at the equator and they're the closest together towards the poles. So they lie in planes that pass through the Earth's axis. So they lie on great circles. Just like before, these yellow planes, they cross through the Earth's center, the Earth's axis. Now, all the meridians, are equal length, and that's because they're all halves of great circles. So a great circle goes all the way around the Earth. A meridian of longitude just goes halfway around the Earth. It goes from the North Pole to the South Pole, but not all the way. Now, those were great circles. A small circle is any circle you can draw on the Earth's surface that is not a great circle, which means any circle you draw on the Earth's surface, like this one, which isn't as big as it possibly could be. And the reason it's not as big as it possibly could be is because this 2D circle has a center here, whereas the sphere that is the Earth has a center here. They don't have the same center. So the 2D circle is not running around the largest possible distance that it could on the Earth's surface. So therefore, it's a small circle. It's what we call a small circle on the Earth. So any circle you draw on the Earth that is not a great circle is automatically a small circle. The reason we care about these small circles is because the parallels of latitude are small circles. So these parallels of latitude, they run in an east to west direction. So they run left to right, essentially, if you look at the globe front on. They're parallel to each other. So this one at the equator, the 0 degrees, and the one at 10 degrees, they're parallel to each other. They run on exactly the same angle. And so is every other one of them. They never meet each other because of that as well. So they cross the prime meridian at right angles. They're perpendicular to the prime meridian because the prime meridian runs up and down, north to south, or south to north. And these parallels of latitude, they run left to right or east to west. Now, let's actually look at using these for some calculations soon. So the reason we care about these great circles is because the shortest distance between any 2 points on the Earth's surface is always along a great circle. Okay, so I've got a good website which demonstrates this. So let's take a look at it here. So this here is showing the shortest possible flight path from Brisbane to London or vice versa. Now, on a 2D map of the world like this, it looks like a curved flight pattern. But if we look at the globe instead, and we rotate to the right angle, we can see that this is actually a straight line. Okay, it's a straight line on the 3D surface of the world, but on the 2D map, it looks like a curved line. The reason for that is because we have to follow a great circle to travel that shortest distance. So that's the fact that this slide is saying. It's saying the shortest distance between 2 points on the surface of the Earth is a distance along a great circle that passes between those 2 points. So let's start using that. Now, the whole purpose of longitude and latitude is to describe positions on the Earth's surface systematically. Without them, we would be limited by agreed upon geographical names. Okay? So, for example, if I wanted to talk about Brisbane, if I wanted to talk about somewhere that is outside of a main city, actually, if I wanted to talk about somewhere that's 50 kilometres northeast of Brisbane, and it doesn't have an agreed upon geographical name, like it's not a town or anything like that, maybe it's just not even a campsite, it's just a blank piece of land. I would have no way of referring to that since it doesn't have a name or an address. Okay, but longitude and latitude, it gives us a way of referring to those points, those places, because every single place on Earth has a longitude and latitude. The way we obtained this system was by fitting a grid. So a grid is usually a 2D shape, but we fit that grid around the surface of a sphere. So we got this diagram here by doing that. Alrighty. So latitudes are the blue lines in this diagram here on the top, and the latitude of a point on the sphere is the elevation of the point from the plane of the equator. Okay. So this point here, we can see on the blue diagram that has a 30 degrees north latitude. Okay, so the reason why we say that's 30 degrees north is because if I took a cross section of the Earth and obtained this diagram down here, that same point, I can see from the center of the Earth, from the equator, it has a 30-degree angle like that. So that's why they have those names of 30 degrees north, 60 degrees north, etc. Now, this point down here is on the 60 degrees south parallel of latitude. So if I look at the cross-section of the Earth, the way we obtained that was it's about here on the Earth's surface, and there's a 60-degree angle between the equator and that point. So that's how the parallels of latitude actually work. They're horizontal lines, but they tell you how much of an angle you are elevated or de-elevated from the equator. Okay, so the equator has a latitude of 0 degrees, and then every point above or below that has a latitude which tells you how many degrees is it offset from the equator. Okay, now longitude actually works the same way, but just for east to west. So lines of longitude are measured in degrees east or west of the prime meridian. So the lines of longitude shown in the diagram opposite this blue one here are the 0 degree line, the 90 degrees west, 90 degrees east, and 180 degrees. So you'll note that we don't add east or west to the 0 or the 180 degrees. Because this 0, you could be 0 degrees east or 0 degrees west of something. It doesn't matter. You're in the same place. Same with the 180. So that's how the longitude lines work. So let's have a look at this in practice. So any point on the Earth's surface can be described by giving its latitude and longitude. For example, Brisbane has a latitude of 27.4698 degrees south and longitude of 153.0251 degrees east. And then there's a few more there as well. So we call those the coordinates of the location. And programs like Google Maps, they'll allow you to enter those numbers in, except you can't use degree symbols very easily, obviously, but you would enter it in like 27.4698, comma, 153.0251. And then Google Maps would actually take you to that location because it's got longitude and latitude data stored into it. You can also use Google Maps to find the latitude and longitude of a location as well. Neither of those are skills that you need in your exam. Alrighty, now we have hemispheres as well. So we can actually divide the Earth into 4 hemispheres if we think about it, because if the Earth is a sphere and we've got the equator divides the Earth into, we've got a northern hemisphere and a southern hemisphere if we divide it like that. Okay. Now we could also cut the Earth down the middle, up and down, rather than left to right like that. So if we do that, make a cut from north to south like that, we get a western hemisphere and an eastern hemisphere. So this is the eastern hemisphere and this is the western hemisphere. So they're all defined through their relationship to the prime meridian for west and east, or the equator as north to south. Now, before we get into any of the questions, this is just a reminder for the way these coordinates are expressed. So we always have latitude first and then longitude. So latitudes are the ones that measure your north-southness compared to the equator, and those are the horizontal lines. And longitudes, they measure how far east or west you are of the prime meridian, and they are the vertical lines. So that's a reminder before we get into these questions. If you are a bit confused at this point, that's okay. Try to really understand what comes next though, because that's the stuff you actually use in practice, what comes next. Which I will have to do in a second video because I'm running out of time on this recording. So please watch the second video.